Magnetic compass error is a lot more complicated because it's dealing with multiple different factors. So we're going to break this down into 3 separate videos. The first one will be discussing variation. There are 2 factors that affect how accurate your magnetic compass is. It's variation and deviation. Variation is caused by the difference in location between the magnetic North Pole and the geographic North Pole. I think you've probably heard this before in like 5th grade, but let's say we're looking at the Earth from above. So down here's the equator, and we're up at the North Pole right here. We know that this is only the North Pole based on the geography or the geometry of the Earth. It's exactly 90 degrees of latitude up above the equator, and it's true all around. Nothing, no factor can change that. We also know that somewhere over here is the magnetic North Pole. This is currently somewhere over in Canada, with a pretty substantial difference between the two. I think it's like 300 miles, potentially more than that. This magnetic North Pole is just the actual pole of the gigantic ferromagnet that is the outer core of the Earth, the molten core that's constantly spinning, causing a magnetic field. That field's North Pole comes out here, and it moves because that's a dynamic system that can't be stable in any way. It's not just based off of math. So it moves relatively slowly, but every year or so it changes by some amount. Nothing huge, but it still drifts a little bit. But this is the pole that magnetic compasses actually point to. So you can imagine if you were right here immediately between the two, a gyroscopic compass would point north there, but a magnetic compass would point north 180 degrees around in the exact opposite direction over there. Now, this isn't a serious problem because nobody's going up here. It's terrible up there. But imagine you're here, closer to the equator. Now, your gyroscopic compass points there, and your magnetic compass points there. This could be a difference of probably 10 degrees. Now, that's not 180 degrees, so it's not completely useless, but this is a substantial difference. This is a difference that's large enough that it will impact the accuracy of your navigation. So you need to be aware of this. And at every single location on the Earth, it's going to change slightly or not slightly. If you're up here, which is pretty far north and also kind of close to right on the directly perpendicular to their axis, that's your gyroscopic compass, that's your magnetic compass. If you're here, it's a lot smaller. And if you're someplace like right here, well, you lucked out, they're perfectly in line with one another. But every location on Earth, this angle changes slightly. And you have to account for that, especially because the magnetic North Pole moves enough that all of these angles are slightly changing every year. I think it could be, or at least thinking about the East Coast of the United States, it could move as much as 15 seconds of arc per year. So a quarter of a degree, or a quarter of a minute, sorry. So it's not huge, but it does happen, meaning all of this is something that must constantly be cataloged. You don't need to just automatically know what your variation is. Every chart has its variation listed on it. I talked about this when we were going over the chart overview, but all of those purple compass roses that were listed all around the chart, each of them had an outer set of degrees and an inner set of degrees. And you could see that the inner set of degrees started at a slightly different location. Here was 0, 0, 0 for the outer one, and here was 0, 0, 0 for the inner one. That's because this one represents true north, and this is your magnetic north. if you looked closely, each of them were very, very ever so slightly different because each one was in a slightly different location. So you don't need to memorize what your variation is. Whenever you're working on a chart, you could go to the nearest compass and find the most accurate variation value for that general area. If you're working off of ecdist, you can automatically calculate it. It'll give you that information for you. Meaning it's relatively easy for Mariner themselves to just keep track of what their variation is because it's present outside of the context of the ship itself. It's known on a public level, but it's really going to cause the bulk of your error for a magnetic compass because it can get up to these pretty significant degree values. If you go in the Atlantic, I believe it increases the further out you go from the East Coast up to like 15 degrees. So it really will have an impact on your navigation.